Today in this video, you should be able to define electricity and tell me about how the electrons move through an electrical circuit. You should also be able to determine if circuits are opened or closed and tell me the difference between an insulator and a conductor. So first, let's start with the definition of electricity. Electricity is a natural phenomenon. Most famously, Benjamin Franklin is known for flying a kite with a key and having it be struck by lightning and quote unquote discovering electricity. So electricity as we know it is defined as the flow of electrical charge. And it takes two different forms: static electricity, that's like if you rub a balloon against your head and your hair stands on end, and current electricity. And current electricity is the only electricity we're going to focus on in our class. So if you remember, electrons have a negative charge, and their opposite charge is positive, and they're attracted to those opposite charges. Electrons in the outer shell are called the valence electrons. You should know that. We've discussed that frequently in this course. And electrons act as charge carriers, which means that each one carries a negative charge. And if we remove one of these electrons from the atom and force it to move, we cause electricity. So let's talk a little bit about what that means. That means that if somehow this valence electron is forced off of this atom, then we have a free electron that is carrying a negative charge. And this negative charge has to go somewhere. So what happens is that free electron eventually finds a new atom to attach onto. And when that electron attaches to this new atom, the negative charge of that electron ejects or pushes off a valence electron from the new atom. And then that new electron floats around and is a free electron, finds another atom to join, and forces another valence electron off of its shell. So this effect is called charge flow. So let's look at this. If this electron right here is forced off, it then forces another electron off, and this electron, it's not the same electron, it's different electrons, but this flow of electrons causes electrical current. So let's talk real quickly about conductors and insulators. We've not explicitly talked about conductors and insulators in this class, but these are terms you should absolutely be familiar with from elementary and middle school science. A conductor is a material where charges flow freely, and that is because they have an outer shell electrons that are easily moved. So these outer shell electrons are easily moved, which makes them excellent conductors of electricity and of heat. Now, insulators, they do not have those outer electrons or valence electrons that are easily movable, and they do not allow that excess charge to move freely. And so non-metallic materials are good insulators and poor conductors. So, like we've talked about, electricity means that the electron moves from atom to atom. It is not the same electron. It is a different electron that is pushed through the entire system. An electrical current system is the system in which electricity travels through. So we're going to talk real quickly about electrical circuits. And circuits are made up of wires and electrical parts like batteries, light bulbs, resistors, motors, and switches. And this is a system in which electricity is able to flow through. Circuits make up everything in our lives. They're in our homes, they're in our cell phones, they're in our iPads, computers. That is how the electrical charge is able to travel throughout an entire piece of electronic work. And a circuit diagram is the shorthand method of describing a working circuit. And it talks to us about what are the things that make up this circuit. Here are some examples of some circuits and the symbols that we use to symbolize these different things. A wire is a straight line. A battery looks like, I'll draw a little bit bigger picture up here. A battery looks something like this. A bulb, mine normally look like this. A resistor, which is something that resists the flow of electricity, looks like that. And then an open switch looks like this. And a closed switch looks like that. So here we can see that there's a battery. The electricity is flowing through this system, which is allowing that light bulb to light up. And this switch right here is closed, which completes the circuit and allows the light bulb to light up. Here, our light bulb would not light up because as our current is flowing, we have an open switch here, and therefore electricity would not flow through. So there are open and closed circuits, like I talked about on the previous page, and we need open and closed circuits to be able to turn on and off our electrical circuits. It'd be pretty terrible if we had lighting in our bedrooms and we could never shut our overhead lights off. So the switches on the wall help open and close the circuit, which allows electricity to flow to your room. Electrical current can only flow when the switch is turned on, and that is called a closed circuit. When the switch is turned off, that is called an open circuit. Oh, yeah, the switch is turned off or it's open, or if it's open, that's called an open circuit, and the electricity is off. So we're going to talk a little bit about two types of circuits. One is called a series circuit. In a series circuit, the same current flows through each resistor, and when one light bulb goes off, they all go off. So you can see that in these series circuits, we have our battery, and then our light bulbs are next to each other in kind of a circle or a series. If one bulb goes out, they all go out. In a parallel circuit, though, it's easier for the electrical current to travel. And in parallel circuits, the voltage stays the same, but there's different currents. And what can happen is that if one light bulb goes off, it does not impact the other light bulb. So if this light bulb goes off, there is still the ability for that current to travel and for this light bulb to light up. If this light bulb goes off, then the current can still travel like this, and this light bulb still stays on. So that's an example of a parallel circuit. So is this a series or a parallel circuit? Well, we can see the charge is able to go into different places, and therefore this is a parallel circuit. It also is super easy to notice because these light bulbs are parallel to each other. This right here is a series circuit. Notice the current can only flow one way. If this light bulb goes off, they all go off. So this is a series circuit. Here, this is also a series circuit. Our electricity is going to flow in the same direction like this, and if one light bulb goes off, they all go off. Electrons flow out of the negative side of a battery through the circuit and back to the positive side of the battery. This is called electron flow. So electrons, they're negatively charged, so it makes sense they would come from the negative side, and they flow back into the positive side of the battery. Oh, one more example. Is this a series or a parallel? And you should be able to know that this is a parallel because there are multiple ways for the current to travel here.